Hi, my name is Mathias Bejean and I'm an organization scientist working specifically in the fields of design and innovation management. And I'm going to present the results of a joint work with André Ehresmann, who is a mathematician working in the field of category theory since many years now, and interested, among other things, in the development of formal approaches to creative cognition. In particular, with Jean-Paul Vanbremeersch, she has developed a distinctive approach to complex systems, named MES for Memory Evolutive Systems, which is the theoretical foundation of our present work in design theory. So, how does it come that an organization scientist meets a mathematician? In fact, while being theoretical, this research work is really motivated by empirical observations in many design fields, including, for instance, engineering design, industrial design, and garden and landscape design. And precisely, when I met André at l'École Normale Supérieure in Paris, I had finished my PhD since about 3 years, but I was still trying to make sense of a personal and very crucial experience as a co-founder of a garden design agency. Because while I already conceptualized some aspects of this experience in my thesis, in particular by analyzing the processes of meaning-making in the design work, I still felt the need to further investigate the collective aspects of designing. For example, in my former agency, discussions about textures often led to creative interactions between clients and designers. As clients were often unaware of how textures, sounds, or light might be used as creative materials, designers often had to educate them to these aspects. Still, it occurred that some clients who developed their own understanding of garden textures, lights, or sounds during the design process conversely modify the way the designers were thinking about these aspects of textures, sounds, light, and so on. What was very striking to me was that in fact it was precisely these types of interactions which led to the most creative and surprising outcomes. So, this is such kind of empirical observations that André and I would like to account for in our present research work. But why using formal approaches to design theory? In fact, the interest of generic or domain-independent theories is acknowledged since the beginning of design research. Among the broad range of approaches that has developed over the last decades, many of them have drawn on formal or mathematical frameworks. The contribution of these research works has been to abstract from one particular design domain to provide general terminologies that describe the process of designing. Doing so, recent design theories aim to develop generic models that could be conceptually sound yet have a simple and practical meaning relevant to the wide spectrum of design practitioners, ranging from design professionals to design teachers. In this paper, we aim at contributing to this field of research by developing a mathematical approach to the process of designing, considered here as a transformative process of a relational design system. We base this approach on a mathematical framework named MES, using notions and tools adapted from category theory. So now, what is category theory and why using it to conceptualize design processes? Category theory, also named CAT, is a contemporary conceptual mathematical domain introduced by MacLean and Eilenberg in the 40s and which tried to reflect the main operations of the working mathematician. As a mathematical domain, CAT thus aims at studying the underlying constructions that are more or less common to the different operations that mathematicians use at work. For example, substructures, quotient structures, products or sums. Traditional approaches to categories therefore search for universal objects, or let's say totalities, which could be entirely characterized in being, for example, topos. Applied to modeling, such approaches thus tend to develop an external point of view of the invariant structure of systems, overhanging the past, present, and future states, which is problematic when trying to integrate becoming and emergence. Departing from this totalistic view, A MES approach does not consider one single category, but a family of categories linked by transitions over time. Technically, this defines a semi-sheaf of categories over a category time. Such approach offers a dynamic view that focuses more on the becoming than on the being of a system. So the basic hypothesis of our work was that such a dynamic category theory, incorporating time, could help conceive generic transformations of objects, structures, and operations in design. Well, in the first part, I will present traditional approaches to transformations and interactions in design theory, as well as how these are conceived in the MES framework. In the second part, I will describe our approach named D-MES with a D for design, which is a particular MES constructed to study the working designers. In the last part, I will give an illustration of the contribution of D-MES by relying on a case study in engineering design. Let's start by looking at transformations and interactions in design. Combining a process and a systemic view, recent design theories or models depict designing as, in quotes, the activity of transforming both the state of a design entity and the state of the associated design process. In this perspective, design situations and design activities are two central concepts. As noted by past research, the concept of design situations accounts for the empirical observation that the combination of the product being designed, the design process, and the design context is important in all design disciplines. The concept of design activities accounts for the fact that in practice, designers aim at transforming a design situation into another one. So the word transformation here is very important, for it adds the notion of intentionality to the more traditional approaches that only consider mutation. In other words, while integrating possibilities for spontaneous mutation, recent models and theories depict design as a set of intentional activities through which a design situation is transformed over time. As this set is often not restricted to the activities of one single designer, it includes the interactions of various intentional entities. We refer to such processes as transformative processes. While sharing the evolutionary or state transition approach to some extent, we believe that it has not developed a satisfying account of creative social interactions in design yet, and that a deeper understanding of such collective aspects is needed. Some other streams of research, like the cognition system approach, the design team mental models approach, or the co-design approach, focus on such collective phenomena, and they have importantly enriched the view of interactions in design. Still, one important difficulty lies in integrating the role of knowledge in these interactions. In particular, there is a need to further conceptualize how a shared memory, robust but flexible, can allow heterogeneous intentional entities to operate in common while preserving each singular view and dynamics over time, and including emotional, non-conscious, and inaccessible processes. As we are not aware of any design theory supporting this view, we analyze these issues within the MES framework and will try to conceptualize and describe how various intentional entities can operate in parallel, both by relying on and shaping a design memory to form creative compositions of new shared objects and processes of different levels of complexity throughout the design process. To do so, we study with working designers within a particular MES that we name D-MES. We first show how D-MES can be used to revise key concepts in design theory. Then we illustrate how D-MES can lead to create new notions which further the understanding of difficult design issues such as the role of emotions and non-conscious or inaccessible processes. Let's start by giving an overview of how revising two key concepts in the design literature that are design situations and design activities. So first, design situations. In the paper we discuss the difficulties raised by this concept. In particular, we emphasize how it often leads to problematic dualisms, especially when dealing with the multiple aspects of a design situation. Here, I just want to explain how we deal with these issues in D-MES. Given a particular design system D, for example my garden design agency, we use specific notions taken from the MES to define a situation for D at a time t as a configuration of D at t. Technically, it is formalized by the hierarchical configuration category HT. In line with past research in design theory, we here not only consider mutation, that is to say, in quotes, natural evolution, but also transformation, that is to say, changes due to design activities. So, second, design activities. Just like design situation, the concept of design activities plays a central role in design theory. In the paper, we also discuss the issues raised by the concept, and in particular by the dualistic and problematic opposition between operation and structure, often known in social science as the agency and structure dilemma. Here we consider that the evolution of D is essentially due to the formation of new components and suppression or decomposition of some existing components. These operations are mainly due to the interactions between what we name local operative dynamics, be they human or non-human. The transitions between two configurations are formalized by the complexification process, which is described in the paper. Here I really want to stress on a key point which relates to the concept of components that I have already used in my presentation. Indeed, in a MES, the general definition of a component is very distinctive, and in fact it has little in common with the more traditional and often reductionist views of components. So here, component C is complex, multifaceted, and evolves over time. As you can see on the two figures, complex means that C admits decompositions and ramifications at lower levels. Note that a ramification is a succession of decompositions in lower levels. Multifaceted means that such decompositions and ramifications are absolutely not reducible to a single combination, and that C can possess multiple decompositions, multiple unconnected decomposition and ramifications in structurally different lower level patterns, through which C can switch while preserving its own complex identity over time. Note also that this definition of component holds for both human and for non-human. Without going into details here, one of the benefits of such an approach to design situation, activities and components is that we can characterize the fruitfulness of D by giving dynamic and structural properties. While integrating traditional views on the role of abstraction, for example, or multiple interpretations in design processes, this approach also allows to account for difficult issues such as the role of shared evocations and inaccessible or non-conscious processes. In the following, we have chosen to present one particular contribution related to the conceptualization of a rich, robust, but flexible design memory. Following the MES general terminology, we define the memory of D-MEM, as a subsystem representing the global memory of D, which enrich whenever a new experience is conducted in D-MES. A component of D-MEM, named record, is multifaceted and can thus have multiple decompositions and ramifications and can evolve over time. A record can be recalled or activated by whichever other component of D-MES, and when two records are often activated together by the same link, then the strength of this link increases. D-MEM consists of records of different modalities, including percepts, affects, concepts, and procepts, which are concepts of procedures that can be seen as forming the know-how of designers. They are described in the paper. I cannot develop here all these notions, and I will above all emphasize the role of particular records named archetypal objects. Archetypal objects are very important. They are higher order components of the memory. They distinguish themselves by the fact that they have many and strong connections, several decompositions and ramifications, and integrating records of different modalities. These archetypal objects form what is named the archetypal core of D-MES. They play a central role in design processes, and they can also account for evocative and non-conscious processes. Let's take an example. Before detailing the case study, just please note that I use the term boundary objects in the sense of Starr and Grismer. So, what is the case about? In fact, a scientific community specialized in Earth monitoring was willing to scrutinize forests thanks to LIDAR technologies. They asked CNES, French Spatial Agency, to design a special mission dedicated to this project, and they recruited other scientists to form the mission team with, for example, in situ forest specialists. The problem was that neither the CNES engineers nor the space or forest scientists did have the same definition of forest. The mission was first abandoned, but then a CNES senior engineer realized that if everybody was talking about forest, no one had the same definition. And she organized several meetings to build, let's say, a common understanding of a forest from a space point of view. This was the LEAF project. This led to a new definition integrating information from all the participants as well as new information. The next slide shows a simplified view of the different stages that lead to the formation of an archetypal object supporting with other archetypal objects innovative design. FE means that it is the forest seen by the engineers, FS by the forest scientists, and FSS by the space scientists. These figures show that first the forest was functioning as a boundary object and initially makes it possible to organize work and coordination among the design team. Second, it shows that the interactions lead to the formation of archetypal objects, in quotes, the specialized forest, and third, how this led to innovative output. Well, now to conclude this presentation, I will just comment a last synthetic figure. This figure shows how the D-MES offers conceptual frameworks which dynamically articulates two key concepts in design theory, which are the design situation and design activities, with a distinctive and very important understanding of the concept of design memory. Thank you very much for your attention. I hope you enjoyed this presentation. Really don't hesitate to contact us, and you may also find more information in the paper and on these sites.